All right, welcome to 3.3 Systems of Linear Inequalities. Our essential question, how do you solve systems of linear inequalities by graphing? We're going to skip the warm-up, but as a reminder, some important things. Remember, this is your y-intercept. I guess we could do the first one here. And so we're going to plot it at 3, and then we do our slope is negative 1/2, so we go down 1 to the right 2, down 1 to the right 2, and that's our line. Something a little bit like that. Okay, now it's solid because we have or equal to, right? So it's greater than or equal to, so the shading is everything above the line. In this case, it would be a dashed line. It'd be less than, so it'd be below. All right, so some vocab here. A system of linear inequalities. Just like a system of equations had equal signs, a system of linear inequalities is just made up of two or more linear inequalities. These are linear inequalities. Okay, so a solution would be the ordered pair that makes all of them true. It's very similar to what we were doing with the shading of the lines, in the warm-up examples. So graphing systems of linear inequalities, well, we'll just take it one by one here. So for the first one, our y-intercept is at -1, then we go up 2 over 1, up 2 over 1, up 2 over 1. That's probably good. And do our best to make a line. It's solid because we have or equal to, right? Now it's everything greater than that, so it'd be everything above the line. Okay. All right, now for the other one, first we need to get in y equals mx plus b. So I'm going to subtract x from both sides. We get y is less than or equal to -x plus 2. Okay, and so our y-intercept is at +2, and then we're going to go down 1 over 1, down 1 over 1. We can also go up 1, left 1, up 1, left 1 if we want. And so then we draw our line, and this one's solid as well. Okay, and it's everything less than that, so it's everything below the line. Okay, and now we ask ourselves, where was the overlap? So the overlap where we have both blue and red is right in here. So that would be our solution area. Any ordered pair in the purple range meets our criteria. So it's kind of in this, just to freehand it a little bit. Everything in this range works. All right, so another example here. With our first one, first we need to add 3x to both sides. So we end up with y is less than 3x minus 4. Okay, so we graph that real quick. 4, and then we go up 3 over 1, up 3 over 1, up 3 over 1. Okay, and we draw our line as best we can. Oh, I made a mistake here. Hopefully you saw it too. It's a dash line. It's not solid, it's dashed. So let me make a dash line here. Oh, sorry about that. We'll try that again. Okay, you get the idea. Then for this one, our intercept is at -3, and we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. We can also go down. It's good, especially when I see like we're already getting away from the other line to head the other way for a little bit. This one's solid. And I forgot to do my shading. So for the blue one, everything is greater than or equal to, so it's everything above. Okay, and then for the red one, it's less than, right? And so it's below. Oops, missed it. Okay, and so where is it both blue and red? It'd be right in this little window right here. So that's our solution area. All right. We're not going to do this one. Just a reminder, if you multiply or divide, I'm not sure if it even plays a part in this one, but I want to just make sure that you remember it. If you multiply or divide by a negative, you switch your sign. Okay, I just want to make sure that you're aware of that. Okay, so tickets to a concert cost $70, or you can get $20 tickets if you have your student ID. Ticket sales must exceed 500,000 for the group to perform. If 20,000 seats are available, how many of each type should be sold? So, how many solutions are there? Well, a combination of $70 tickets and $20 tickets, and it has to exceed 500,000. There's a ton. Okay, so we're gonna make our equation. We'll graph them, and then we'll see what the solution area is. Okay, so I would say let's do for the $70 tickets. Those we'll just say T for tickets, and the $20 tickets. Or actually, we'll just say T for regular tickets, and then we'll say D for discount. That'd be like the $20 tickets. Okay, so for the first one here, we're going to talk about the cost of the tickets. So $70 for every regular price ticket, plus $20 for every discounted ticket, and it has to exceed. So that means it has to be greater than 500,000. Okay. Now the other one, we'll make that one in red. There needs to be 20,000. There's 20,000 seats available. Okay, so the number of regular tickets plus the number of discounted tickets has to be less than or equal to 20,000 because there's only 20,000 seats, so you can't have more than 20,000 tickets sold. So it has to be less than or equal to. So we have our two equations. Okay. And we could go ahead and graph this, and I don't believe we will here, but just the concept of getting our solutions or a system of inequalities together. $70 for every regular price ticket, $20 for every discounted ticket has to be greater than, it has to exceed 500,000, and then the total number of tickets, so the regular plus the discounted, has to be less than or equal to 20,000 because there's only 20,000 seats available. Okay, so we can graph this. We're not going to. And then you would shade, and wherever the shade overlap is, that's where your answer would be. All right, so now we're going to incorporate absolute value. And remember, absolute value makes a V. Okay, and so here, this is going to be flipped and stretched by 3. Stretch. There we go. Now this is saying that we go to the left 2. Remember, it's backwards of what you think, and then this one is up 1. Okay, so, and we're going to have a dotted line. Okay, so our vertex, left 2, up 1. So left 2, up 1. This is where our vertex is. And then this is really our slope, right? So we're going to go down 3. 1, 2, 3, and over 1. And then we can do the same thing. It's mirrored, right? Okay, and remember that it is a dotted line. So I'm doing this with a mouse, not the easiest thing to do. So there's that, and then when we shade it, it's going to be less than, and so it's going to be inside of the absolute values. Okay. Now for this one, we'll make it green. This is just a line, so we're going to go down 5. 1, 2, 3, 4, 5. And then our slope is -1, so we're going to go down 1 over 1, down 1 over 1. We can also go up 1, up 1. That would just be more useful since that's kind of what our graph is. And it's solid line because it has the bar, right? Okay, and then it's everything greater than. So it's everything above the line. Okay, where's our overlap? Our overlap is right in this little nook. That's where overlap is. All right. So here are your practice problems, and that's section 3.